Hello, everyone. We have 1 minute to go. Just to confirm that you can hear me and you can see my screen. Can someone confirm that you can hear me and you can see my screen? Thank you, May. Thank you so much. Thank you, Abdul. All right, so let me check. Did I record this event? Okay, it is recorded. All right. Any questions? Anything? Thank you, Jackie. Okay, it is 1 o'clock. I want to respect your time. Today is our last lecture. I will do the final review. Sorry for the typo. Our final exam is held on April 26th from 7 p.m. to 10 p.m. It is on Sakai. It is you can write a test at your home, okay? Not computer lab. It is a virtual computer test. Go to Sakai, then test quizzes, final exam. Final exam cover weeks 1 to 10, but with much more focus on week 5 to week 10. Okay. So today I'm going to go over, go backward. So we'll start with week 10. Remember in week 10, we did chi-square test and logistic regression. So I will go backward again. The format of the test, I have probably some multiple choice questions, short answer. Basically, those two types of questions. You need to know both at the concept level and calculation level. There will be no requirement to, if you can access SPSS, that would be great, because some calculations, if you have SPSS, will improve your efficiency. However, if you do not access SPSS, you can still do it by using the formulas, using Excel, okay? So that is, so it is best you can have access to SPSS so that you can have some questions, not a lot, just some questions done through SPSS. Otherwise, you can stick with the formulas, calculation by hand, or with the help from Excel. Okay. So that is the format. The content I will go over briefly. You have plenty of time to complete the exam. It is 3 hours. I guess most students may complete within 2 hours. You don't need that 3 whole hours, but I would give you that 3-hour time frame, okay? The questions, you cannot go back to the previous question. It is a prevent, so make sure you answer each question accurately, okay? So that is the structure, format, and the logistics about the final exam. Any questions? I'll try to see the chart area. Okay. Let's see. All right. So please feel free to either type in your question in chat area or directly speak up. All right, so let's go item by item. Start with chi-square test. It is in textbook lesson 40 and lesson 41. But remember, in the live lecture, I gave you extra examples. I hope you'll go through the live lecture for week 10, okay, both chi-square test and logistic regressions. For logistic regressions, you need to know how to define path for the given problem. Okay, how to define path for the given problem, and how to calculate the odds for the given problem, and how to interpret output from logistic model. So those are for logistic regression. I will talk specifically for chi-square later. Okay, so for now, I talk the logistic regression. So now in week 9, we did internal consistency and item analysis. For this, it is in lesson 37, lesson 38. You need to know the method for estimating a reliability coefficient. There are 3 methods. The internal consistency has 2 methods, split half and the coefficient alpha. Okay. And you also need to know the 3 types of applications of internal consistency estimates. Be able to interpret the output from internal consistency and item analysis. I usually will take an output from the class example or from exercise with modification of change some numbers, and then I ask you for interpretation. I will change number. Sometimes I don't change number. Okay. So that is week 9. And in week 8, we did factor analysis. Again, 2 requirements. 1, what is the purpose of factor analysis? What is the function of eigenvalue? And explain the output from factor analysis. I will give you output from factor analysis in SPSS. And then in week 7, we did discriminant analysis. Again, go over the class notes in week 7. There are lots of questions about this week 7, discriminant analysis. Okay, and targeting the output as well as the basic concept. We didn't have lecture for week 6 because that was our midterm. And week 5, we did multiple regressions. Okay, so far I mentioned, actually my test questions are based on I have discussed so far. Because the contents are interconnected, I didn't say you are not going to test week 1 to week 4. Okay, but my questions are coming from week 5, week 7, week 8, week 9, week 10. Those are my questions coming from. Sometimes questions have connection with maybe week 4, week 3. Okay. So that is the outline, what you are expect about the final exam. And next, I will give you some specific point you must grasp this point, because, for example, the output from the regression, this format, and also as well as the ANOVA test, the output similar like this. Okay, try to make it fit. Okay, so you need to understand each and every component in this output, as well as the relationship among the numbers. Okay, so the multiple R, it is a Pierce linear correlation coefficient. It could be a positive number, it could be a negative number. Okay. And R square obvious is a positive number between 0 and 1. The bigger the R square, the better the model. Adjusted R square is adjusted for sample size and other factors. And standard error. Standard error, it is actually the square root of MSR or E. So this number is MSE, mean square due to error. Okay, so if you take square root of this number, you get standard error. So those are the relationship between these two, this number and this number. Number of observations is the sample size. Okay. And also the very important is the R square, interpretation of R square. Usually we interpret to percentage. So 68.9% of variation in Y are due to those X, whatever it is X1, X2, or many X, or just one X. And this ANOVA table start with the last one. You need to know the significant F. This is the p-value. When p-value is smaller than alpha, the model is significant. It is a good model. And the test statistic is F. How do you get this number? You use this number. This is a mean square due to regression, MSR, divided by this number. You get F. So there are relationships among these three numbers. So for example, this F equal to MSR over MSE. Okay. So if I give you two numbers, you would be able to compute the other number. Okay. And this number here, this is the SSR sum of square for regression. So this number is SSR, and the number below it is SSE, sum of square due to error. And the relationship between MSR and SSR is that, so before I explain the relationship, degree of freedom, this is the number of independent variable. So K, independent variable. I have two independent variable. Okay. And this degree of freedom for residue is N minus K minus 1. Obviously, these two degrees of freedom added together is 25. And now I will explain the relationship between how do you get mean square due to regression? Use the sum of square due to regression over number of independent variables. So how do you get mean square due to error? Use the sum of square due to error divided by N minus K minus 1. Okay. And sometimes the question could be phrased as, what is the degree of freedom for test statistic F? The answer is 2 and 23. You need 2 degrees of freedoms for test statistic F. Okay. So that is an ANOVA table, very important. Remember when we did the ANOVA test to compare multiple means, we also have similar layout. Okay. The next one is in multiple regression, you can write down the equation based on coefficient. Based on these three numbers, you can write down the equation. So if this example is the relationship between Y, X1, X2. So based on this coefficient, you can write down Y equal to constant plus this capital is X1, wages is X2, okay? 0.1245 X1 plus 7.0762 X2. And once you have this equation, you can make a prediction given x1 and x2 to predict y. So again, this for final exam, for this part, the summary output, there are several questions about this part. So very important, okay, this part from SPSS output, be able to interpret. And then be able to interpret in ANOVA test, when we test 3 or more population means, if we conclude at least one population means is different from others, and if you want to do the follow-up test, there are several methods. One method is 2K Chroma procedure. So you need to know what does this procedure do. And then for correlation, this correlation actually in week 4. So week 4 still be tested, okay? Correlation coefficient. You are expected to calculate the correlation. You can do the calculation by formula. It is very complicated formula. Or you can do the correlation using Excel. I would strongly suggest you use Excel to calculate correlation. The Excel function is correl. So I will give you a small example, okay? So if I have, I just randomly type in any number, okay? If maybe continue typing. If I have some data, okay? So that is not actual. Just for example, this is a data, and then I have another set of data. You want to calculate the correlation between this is array 1, this is array 2. Just use Excel correl. So just type in equal CORREL, opening bracket. This is array 1. This is array 2. And you can get correlation between those data set 1 and data set 2. Again, you can use SPSS to do this as well. But my exam questions are designed such that if you don't have access to SPSS, you would still be able to answer the question. But if you can access SPSS, that would be great, okay? So that is, there are several questions to calculate correlation coefficient, giving you original data here. So that is a correlation in week 4, still be tested. And then discriminant analysis, that is actually week 7. In week 7, and it is in lesson 35, we did a discriminant analysis. So pay attention to this chapter, discriminant analysis. Many questions about this. For example, how do you know how many discriminant analysis functions do I need? Do I need 2 functions? Do I need 3 functions? Remember, we created output, the decrew of the graph. Remember the graph like this. Okay, so based on this graph, you can calculate, and also based on the numeric output. So go through the live lecture notes for our lecture recording, week 7. Okay, so number of discriminant functions and the eigenvalue. What is the function of eigenvalue? How do you draw conclusion about number of discriminant functions based on eigenvalues? The properties of eigenvalue for the components. And also this correlation, canonical correlation. What is the relationship between eigenvalue and canonical correlation? There is an equation between these 2 terms. Okay. And then effect size. There's an equation between canonical correlation and effect size. I did detailed in the lecture. Okay. And also, how do you write down what is the discriminant function looks like based on the parameters estimate from SPSS? Write down discriminant function. Okay. And again, how many factors being extracted? Okay. So this is this part. And also this one here, reversed items. When you do data analysis, sometimes you need to reverse items to make sure all the data items goes into the same direction. Remember, we did 2 lessons about emotion control. Okay, study that example to see why you need to reverse some items and read exam questions carefully. If I mention emotion control, any items related to openly express my emotions will be reversed. On the other hand, if I am assessing openly express my emotions, so my target, my research items are about openly express emotions, and then any items about emotion control will be reversed. So read questions carefully. What items will be assessed? Then you reverse the one that has opposite direction so that all the items go to the same direction. Okay. So that is some details about some specific final exam. So maybe I want to add, did I say, focus on maybe week 4 to week 4 actually just that linear correlation coefficient I showed you co-real function. Linear correlation function that is in lesson 31, 32, 33. Okay. Any questions? Anything? Any questions? We just have a short lesson today. The rest of the time, it is just individual consultation, question and answer period. If I were you, I will go over. Remember each time we do. Oh, by the way, some students ask, where is lecture recordings? Each time after we finish the class, I post the lecture recording on Sakai. Lecture recordings here. Those are all the lecture recordings in YouTube. Okay, so it is on Sakai. Okay. Okay, any questions? Anything? Okay, I'm going to stop recording. I will open it up for any questions. Okay. So this is a very short stop recording.